let me snip this guy, and then I'll give you time to copy it. And in the meantime, I'll pause this thing so you can. Okay? Everybody with me on that? Okay. So then it tells you to make a sketch. So step number 2, make a sketch. So I'm going to draw a sketch on the side. And my complex number is -1 plus I. So it's going to end up here like -1 plus I. It ends up here. Okay? And the angle that I want. So a complex number ends up in a particular quadrant. Okay? In this case, it ends up in which quadrant? 2. Okay? This is my angle. That's my R, or radius. Okay? That's my R. And I've already found R is √2. Then from my formula that theta is equal to tangent inverse B over A. Okay? I get this equation, from which I get that equation, from which I get that. Everybody see where the 3 pi over 4 is coming from? Yeah, why is it 3 pi over 4? Leah? That's like saying, yeah, 1 plus 1 is 2. Oh, 2 is 1 plus 1. Can you have a better explanation, Sina? No, it's not. It's not. Now. So, okay, speak up loudly so it gets recorded now. Okay, so in your friends table, you go find where tangent is equal to 1. You find the angle that it corresponds to is pi over 4. And that angle that the friends table is talking about is this angle here. So that angle is pi over 4, but that's not what you want. You want this angle. So it'll be pi minus pi over 4, which is 3 pi over 4. Okay? All right? And then you will finally write your answer in this form here. So the complex number z becomes equal to square root of 2 cosine 3 pi over 4 plus I sine 3 pi over 4. Okay, so that's your final answer. Notice that these two angles here, this one and this one, they are always the same. If they are not, you are smoking somewhere somehow. Okay, those two angles have to be the same. All right? Okay, so that's the recipe, and I showed you how to cook this stuff. Yes, done? Okay? So now what I want you to do is follow the recipe and cook me this stuff. Going from standard to trig or polar, you got to go from polar to standard. Okay, you got to do both ways. So let's going from trig form or polar form to standard. It's not too bad. Okay, it's a lot easier than the other way. You still need to know your friends, though. Okay, you still need to know your friends. Eric and Chris, hope you're having fun there. We're having more fun, okay, with Sina and Jaco and me. We've got a party. We've got a party going on here, okay? And we are learning math at the same time, okay? I don't know about you guys. All right. So I'm going to graph this thing so that I know whether cosine is positive or not, or sine is positive or not. So 5 pi over 3 turns out to be 300 degrees. So the angle is actually in the fourth quadrant. Okay? It's out here. And this is 300 degrees, or 5 pi over 3. Okay? So then it becomes √3 What's cosine of 5 pi over 3? Using your friends. Chris, I will have to move you now. Last warning. Last warning. Okay? Cosine 5 pi over 3. And you're not going to move next to Ferris anyway, so you're going to move somewhere else. Okay? Someone, cosine 5 pi over 3. 1/2. Positive, negative. Okay? Because of this. Okay, so that's going to be 1/2. What about sine 5 pi over 3? Negative root 3 over 2. So it's going to be negative I root 3 over 2. And you move the root 3, distribute it out, so you get root 3 over 2 minus 3i. Notice how I change it now to 3i. Because there isn't a radical, so I move the number in front of I, okay? And then this guy stays as 2. Is everybody with me on that? Okay? So going from trig to standard is a lot easier than the other way. But it still means you got to know your friends, okay? Now there are some questions in your book that don't have friendly angles. Well, you've got a calculator, so use it. Okay, use it.